verify that these two functions really are inverses, and maybe that's what you're going to be asked to do. Here's a function, here's another function. Are they inverses? One thing that you can do is plug one function into the other and vice versa, and make sure you get x, right? So this is g of g inverse of x, which is g of, what was g inverse? I forgot already. Cube root of x minus 1 plus 2. And I like doing it this way because you're going to see more explicitly how this plays out. Okay, so I'm going to take this number here and I'm going to plug that into g. Right? So if I take all that mess there and plug it in for x right there, then that is the cube root of x minus 1 plus 2, all that right there, minus 2 cubed plus 1. And as you start doing your order of operations on this, you're going to see one by one, each and every single one of those operations is going to cancel. So the adding 2 and the subtracting 2 cancel. Then you're cubing a cube root, right? So those cancel. And then you have x minus 1 plus 1. Those cancel, and you're left with x. Awesome. All right, so let's go back to this equation. We never found the equation for the inverse, right? I gave you the equation for the original function, but I didn't give you the equation for the inverse. So, since we have an equation, let's find it. Let's find the inverse using this method. Okay? Can I erase this? Are we done with this? I'm fairly done with it. Okay. I was going to ask if y'all are being quiet today because, like, this is you being vindictive because you wanted to see your test grades first and you didn't really want to learn any of this. But you're quiet anyway. I just remembered, like, y'all have an aversion at answering my question. So, f of x equals x squared minus 3. If I'm going to find the inverse using the equation, I've got to switch x's and y. So, let me rewrite that as y equals x squared minus 3. And so then, one way to write the inverse of that equation is, yeah. But solve for y. So if I'm solving for y, I'm going to add the 3 over, right? So y squared equals x plus 3. Are y'all cool with me doing switching like that? All right. Now this is going to be like the 20th time I've asked you this. So you have every reason to get this right. If I'm trying to solve for y, I've got to get rid of my squaring, right? How do I get rid of squaring? Plus or minus. You guys nailed it on the first try. I'm so proud. I'm gonna write that on my blog tonight. No, I'm not. I might. No, I probably won't. Because I'm going to be grading stinking other tests. Okay. So the square root by itself doesn't do it. It's got to be the positive and the negative square root of x plus 3. Isn't in that 2 equations? Really? So y equals the positive square root of x plus 3, or y equals the negative square root of x plus 3. You remember what the graphs for those look like, right? What does the graph of this look like? The square curve is this one, right? But because I'm adding 3 inside the square root, that shifts it left 3 units. So 1, 2, 3. It's that one, right? And what's the only difference between this equation and that equation? That negative sign. And the negative is outside the radical, right? And when we had negatives, that was a reflection. So which way am I reflecting that if it's outside? You remember? It's like this, right? So if I take this and reflect it this way, I get that, right? But you already knew that, right? Because what was the inverse? It was this guy right here. The top part of this was y equals the positive square root of x plus 3, and the bottom part was y equals the negative square root of x plus 3. You gotta admit, deep down, despite your like hatred of math, that's kind of cool, right? Just a little bit, like 1%. Give me 1%. Did you say 0.1%? Turn that off.